Welcome all. This is x power 2, y power 3, dx, dy. If you get this way, and I will give limits 0 to 1, 0 to 2. There are two ways you can do. The general notation is, if I write here, double integration, any function of x and y, any function of x and y, it could be x plus y, x square plus y square, x square, y square, whatever, then dx, dy. Sometimes there is a problem deciding which limit for which variable. So in some books they mention like this also, y limits are for this, x limits are for this. Let's start this way. Yeah, you'll be able to know properly when you do a lot of problems. Even if you know, then also there is always a doubt whether x limits are for the first ones or the second ones. In any case, if you accept this one, then how can you solve this problem? That is the next one. So if you try to solve this problem, there are two ways. The first way is you integrate with respect to x, then you integrate with respect to y. Suppose this one I will integrate with respect to x, and I will use x limits. And I'll write method 2 here. Integrate with respect to x, take x.
Okay.
Yeah. And when you integrate with respect to x, you have to keep y constant. Yeah. In the second one, you integrate with respect to y and put y limits here, 0 to 1. And while integrating with respect to y, keep x constant. Okay. Now do it. The first one. Yeah. Yes, correct. Okay. This is one part. We have to do the other part as well. Suppose you have started with this one with respect to x, then you have to do the y part as well. Okay.
Okay.
That will follow. See, this is the question. Okay. Suppose you are doing by method 2. I've taken with respect to y. You have to write this way. You have to write 0 to 2. Okay, I've written 0 to 1 here. Fine. 0 to 1 dy. Already we have written this. Then this one you have to, whatever you get, that will be function of x, because you are replacing y. That will be function of x. That you have to integrate with respect to x with x limits. X limits are 0 to 2. Got it? Yeah, it's like pairing. It's like pairing. See, we have taken y first, then we'll consider x. Two are there, right? So we have taken y first, then we have to take x anyway. Not either or. What I wanted to say is, you start with y, then you have to do that
Go
part,
to X.
dx. You start with x, then you go to y. Okay. How about this?
Fine.
Just matching, right?
Yeah.
Okay. So you can do by either method. Now, next example. Suppose I'll write 2x plus y square dx dy 0 to 2, 0 to 3. This function we have 2x plus y square. And if these are not mentioned, the limits are not mentioned, then in some books they take x limits 0 to 2 and y limits 0 to 3. In some books they take y limits 0 to 2, x limits 0 to 3. However, it depends on the particular book. But later on what will happen is you will be able to know seeing x variable. Now all are constants. We'll go to the next part. These are the easy ones. So once we do this problem, then you will be able to know what are the limits actually. Just take whatever way it is. You can take in order, and these are x limits. Okay, so do by method 1. Okay, that's good. Yeah, you can differentiate with respect to y. So this is 2xy, right? 9, if I'm not wrong. But I've written 0 to 3 here. Already wrote, I didn't want to delete that one. So let's do by method 1 as well. Okay. So we have to put x2, so it will be 2y square. Okay. You got 30? Okay. But I got 22 here. See, 4 plus 2y square. That's why we have to integrate once again. Okay. It will be like this. This is one line. And then we have another line here, x-axis. Suppose you want to integrate here, and this is the area. On this area, you have to integrate. Limits, we'll go to that. So the procedure is, you have to draw two lines parallel to axis, okay? And then you have to go this way. You will reach here. You have to write the value of y here. Suppose equation of this line is x is equal to a, and equation of this line is x is equal to b. Why I'm writing only x? Because these are parallel lines, right? This is also parallel to x-axis, so this will be y is equal to a. And this equation of graph, it could be y is any function of x. Better we write phi x, any function of x, or we'll write fx gx instead of 5. That will not be confusing. So suppose this is f of x and this is g of x. So if this is the area E, over E, double integration definition is dx dy. Then you have to write dx, we'll do it later, and then f dy, whatever is the function, you write the limits of x here, a to b, here a to b is the area, name of the area. And then when you go this way, you have to write the value of y here and the value of y here. This way you have to integrate. So
Okay.
if you ask me, we didn't follow any such thing because
Yeah.
because these are constants. So when you have limit constants, you need not worry. Directly use that way. However, if limit is function of x, remember you have to write dy here, and then after evaluating this one, suppose this is 5x, you need to integrate a to b dx into 5x, that is 5x dx, that way. Where I've repeated?
Of
No, not area. That is called double integral. Like suppose single integral, I have numbers, just a minute. This is there. So on this line, I will define a function. I'm integrating x squared dx, that means 2 to 5. That means between 2 to 5, I will square all the numbers. I will square all numbers, not only 2, 3, 4, 5, all numbers I will try to square.
yeah.
And then I will add, I'm summing the square numbers between 2 to 5. That is
Understood.
single
Okay. Okay.
because there are infinite number of numbers, I just can't add all
Understood.
the numbers. So we use integration. That is called line integral. Okay. Line integral means single integral. Double integration, what will happen is, suppose you have one area and you have a function defined on this area, f of xy is x square plus y square. And when we talk about area consists of points, right? At each point there is a coordinate x and y, right? Suppose you have a 2, 1 point, so 2 square plus 1 square, right?
Yeah.
So you, for this point, we have a x and y, you find x square plus y square. At this point, you find x square plus y square. At this point, you find x square plus y square. At this point, you find x square plus y square. At this point, you find x square plus y square. Like that, on this area, at all points, you find x square plus y square. Then sum those things. That is double integration.
Okay.
And to make it easy, if you tell me, no, I just want to know the length of this line and I want to find the area of this figure using double integration. We already know using single integration also we can find the area bounded by 2 graphs or bounded by 1 graph, 2 lines parallel to y-axis and x-axis. We have already done that. Now we'll do today this one, we'll find area using double integration. No, because I'm not finding area will come as a particular case. When this function is 1, that means I will not see the variation of each point, only I will add the points. I will add the points means what? This is 1. Okay. So if I write only dx dy, double integration, then I will get area. The reasoning is each point, nothing is there, function is 1. So for each point, I will take 1 point only. I will not see the variation of these points. I will not subject all the points to a mathematical function. So basically, I'm adding all points, and that way I'll get the area of the circle.
Okay.
So if there is no function here, you will get area. That also will check. Even when I talked about line integral, if I make it 1, then you will get length of the rod. Suppose this is a rod, you want to length of the rod. You take 1 dx, only dx, single integration dx. This line integral, you will get length, here you get area. The meaning of double integration is not only we add things, but we add things after passing through the function. Okay.
Okay.
Suppose I have 10 rupees and my friend is 20 rupees. There is a machine. In that machine, you have to put 10 rupees and it's a kind of a gambling. You get some amount, okay? After coming from the machine, it might be 50, 25, whatever, okay? And then my friend also, he will put 20. He might get, suppose 25. We'll add. So this is the final. So this is the answer, 75. Our total money will be 75, right? After passing through the machine. Before passing through the machine, it's 30, right?
Yeah.
That way only. You are using a function, you are passing all the points to that function, and then you are summing, or directly you are summing the points. That's what we are saying. Okay, so both of the things will do. Things will be clearer. Yeah. As I already mentioned, what will happen is when you want to find, suppose, let me take another line. Suppose I have another line like this. Can you tell me the equation of the line? No C here, right? C 0. Okay. So this one is 0 And if you remember, when you studied equation of a line, I mean, whenever you take, it doesn't matter. You are taking parallel to x-axis or y-axis, one variable will be absent, right? Suppose I write x here, x this here. Can you tell me the equation of x-axis? Right. Okay. So you know equation of x-axis. Equation of y-axis x0, right? Okay. How about this equation of this line? The slanted one. There is no c here. Is called mx. Even I will not consider y mx because I try to draw a line which will bisect the 90 degree. That means 45 degree. You can assume the angle between the line and x-axis is 45 degree. Then what will be the equation of the line? Suppose this is 40. Okay, slope is 1045.
Yeah.
And that is 1. And equation y is equal to mx. So m is 1 here. Okay. So what will be given? Let me write. The question will be given this way. Double integrate over E, where E is the area bounded by the lines x0, x5, y0, yx I can write, y2x.
Area bounded.
Okay. Now whatever function I will write, that is like machine. Okay. The variation of the points, but I'll write that later. Maybe I will write x plus y, x² y², whatever I want, I will write that. But that's not important. This is important. What are the limits? See here x0 and here x is equal to 5. And this equation y0, you only said, you know it. And the equation of this line is yx. If yx is given, you will be able to draw these 4 lines, right? 0 y-axis we know, y0 x-axis we know, x5 that is a line parallel to y-axis. Okay. The only thing is yx, that is the equation of a straight line. If you want, you can take 2 points and you can find this. Now this is the area. This is the area. On this area, there are infinite number of points. So all these points, they have to pass through the function I will write here. And whatever numbers you get, the new numbers, those things you have to sum. That is the meaning of double integration. Okay. Suppose I will write x² plus y² here. More than the meaning, initially you should be able to evaluate. How can you evaluate this one? There are 2 ways. You keep the whole area between 2 lines parallel to y-axis this way. You have to travel. It's like moving from this point, from bottom to top, you can say. And suppose you are traveling this way. These are your train lines. You should not go here and there, and you will reach here. And these 2 equations you have to write here. Suppose that is equal to, I will write dx, then whatever function is given, that I will write dy. You have to tell me how this is different from what you have already done today. Now the limits, when I set, the limits are 0 to 5 given between 2 parallel lines. These lines will always be parallel to y-axis. Here one line is y-axis, one line is overlapping with y-axis, it doesn't matter. But the line, 2 lines, they must be parallel to y-axis. And then you are going this way, you have to write the value of y here. y0, we know, so y 0. Now we have to go further, then you have to reach here or here, whatever. Yes, so you have to write the value of y. Y is equal to x, so you have to write x. This you need to evaluate. Now tell me how this is different from what you've already done. Yeah, so what we have done just now is, I will show you in the graph. We have completed this one. This kind of a thing we have done on this area. It was kind of a rectangle. See, x is there, right? So if you write it 7, then they're exactly same, right? We have done this kind of a problem. 0 to 5, 0 to 7, remember? Shall I show you? Shall I show you that? See here, the first problem, 0 to 1, 0 to 2, right? And then 0 to 3, 0 to 2. Where things changed, if you mark here, I've written a function of x, right? And that's how when x and y both are there, you will get a slanted line. The line is no more parallel. So you are finding the double integration on a rectangle before. Okay. Now yes, exactly. Now we have here, I wrote 7, right? Okay. Let me replace it by 7. Now if you want to find the area of this, then you have to omit this x² plus y². That's all. If the function is 1, if f of xy is 1, then you get area. So we are doing more than area here, right? We have a machine. Yeah. Where you confused? Oh, wrongly I deleted the original one. Yes. Okay, here also. Okay, let's complete this. You do this part first of all. The inner part, this one. And we have to do in that order only. Yeah. Okay, 625 by 3. Okay, fine. Now there is something called change the order of integration. Okay, we'll go to that, but we'll try to do this by the other method as well. Yeah, so when you do by the other method, then you have to keep the whole area, whatever area you got here, that area between two lines parallel to y-axis, the same area, you have to do this way. Suppose I'll draw one line here. It should pass through this point, and this line should be parallel to y-axis, and you have to cover the whole area by traveling. Okay, so suppose you travel this way now, where you will reach first? No, but we will not consider this. Why? I would like to hear this answer from you. Yes.
But yep.
You have to draw the diagram actually. And first of all, you know y0, similar to this, I will write here dy. y0 I know already. Here y0. Here also y value I have to write before proceeding further. And that you will be able to know only when you know this point. Because y is equal to x and this is 5, the intersection you can solve x is equal to 5 here. Yes, y is also equal to 5. This is 5, 5. So the equation of the line will be y is equal to 5. So when you write y0 and y5, it will be between 0 to 5. So 0 to 5. Then we'll write f dx and we'll try to go here. We'll reach first here. So tell me what I need to write here. This line equation, remember. Equation of this line I have to, from equation of this line, I have to write here. What I need to write? X value in terms of y. What is that? Exactly. I'll not write x. And that is how things will be different. I will show you here. Here I showed this way, right? Y is a function of x, then another function of x. Okay. However, the same thing if you write this way, and you need to cover this area like this, then what will happen? You have to write y values. Y is equal to c, y is equal to d. Then when you are going here, you have to write the value of y here, write the value of y here, not x. Now going back to that one, here y is x value in terms of y. What I wrote here, x value in terms, okay, this was fine. Here x value in terms of y, here x value in terms of y. Here x value in terms of y I got, then here, then I have to travel further. I will reach here. Tell me here what is the value of x in terms of y or constant, whatever. 5, right? Because the equation of whole line is y is equal to x is equal to 5. So I'll write 5 here. And you need to integrate, match the answer. This is called changing the order of integration. Integrate this with respect to x, keeping y constant, and put the limits. And once it's over, we'll directly do with respect to y, whatever we'll get. This will be x power 3 by 3. This will be y square x between y to 5. Now when I say y to 5, then 0 to 5 dy I will write within this one. We'll evaluate 125 by 3. Then 5 I have to put in x, 5 y square, minus y I have to put in x. This is a bit bigger. You have to check it if I'm wrong. Yeah, because we don't have any 0 now, y to 5. That's why things are a bit different. You have to solve it and you have to match the answer 625 by 3. Yeah, you have to integrate again with respect to y, put the limits of y, finally you get the answer. And they must match. Matching? Okay, that's great. Now suppose you like to find, yeah, in couple of cases I said the students, if you want to go to heaven, okay, that is one way. If you go by train, that's one way. You remember this way. If you go to heaven, that means you are going from here to heaven, right? It's like you're catching a flight, direct flight. That's not possible always for all category of people. But yeah, that's one way. The other way is this way. Like we will go by train. Train, we say patri, right? Train means we have the train lines, right? The train lines, that means we'll go on floor and here going to top, right? Heaven, this direction. You can remember this way. Always the first two limits will be numbers. That will always be easy. The second part you have to find, you have to see the enclosing area. Okay. Suppose the area enclosed is this way, okay. And you are going this way. Then what will happen? These two you must be knowing. You have to keep the whole area between two lines. These two you will write anyway. These will be numbers. Now when you go this, you will reach here. Okay. But further when you go, you will come across two lines, right?
Yeah.
So then there will be a problem. You have to divide further into two parts. You have to do two integration. We have not gone to that complexity level. However, if you in these problems, you have to do by this method. What will happen is the whole area is between these two lines. If you go here, you will get one line and then one line. That's over. This area is over. So in this case, this method is better, like train line method. Okay, they are given here x0, x5. First, see, you see what is G. Suppose x0 is given. I'll draw the graph first of all, and I will see that equation of y-axis is x0. This I already know. The first one is over. Then x is 5. This is x5. Then the second one is over. And then y0 is x-axis. This is the third one. And then the fourth one, yx, this is yx. So these are the lines given. The area bounded by this. So on this, we have to do double integration. Then try to keep the whole area between two lines parallel to x-axis. Already there. So we have not done anything extra. However, in the other case, this area, sometimes you will get a graph like this. Then what you need to do is you have to draw one line like this. You have to draw a line like this. Then you have to travel. Here in this case, what happened? Automatically it happened. So you had no doubt. But in the other case, you had to draw a line. Now you must be thinking, okay, how can I know? How can I draw a line, right? Stop thinking that. It requires practice. You will be able to know. We'll do plenty of problems. There will be nothing. I mean, no single problem left for you to do. That means what on whatever area you are integrating, that will be between these two lines. Okay, this triangle you are seeing, that is between these two lines. Then two more. See, this area lies between these two lines. This line is this one. This line is this one. Then you have to travel like this. You will reach here. Then here. These 2 points you need to. This point, when I say you write, take this point, this point, this point, this point, the equation is same. Here on this point, this point, this point, equation is same. See, equation x5 is here. This line I know. And equation of this line is y is equal to x. So x value here is y. And x value here is 5. That's why we have written y and 5. Here, value of x on this line. Yeah, on this line. Value of x is y, right? And what is the value of x? Yeah, what is the value of x here on this line?